Morning guys and girls. This one is a video on the rules around logarithms and how to manipulate them. They work in a very similar way to indice rules, and actually you use indice rules to prove them. You don't actually need to know the proof, so we're limited to a 15-minute video. I'm not going to go through the proofs, you can look them up if you want. So there's 4 that you need to know. You've got log to base a, so any base of xy is log to base a of x plus log to base a of y. And they are interchangeable. In other words, if you've got a product in your logarithm, you can split it up with an addition, just like you would do with an index. For example, a to the x times a to the y is a to the x plus y. So when they're multiplied together, you get a plus sign. Similarly, if it's a divide, so log to base a of x over y, same as indice rules, you get a minus. Then we have log to base a of 1 always being 0, because you know that anything to the power of 0 is always 1, so inverse of that means the log of 1 must always be 0. And the last one, we've got log to base a of x to the power of k. The power drops down to the front, and you're just left with the x in there. Again, all those proofs are available if you wish to look for them. I've just got 3 quick examples on how you would use these. I've got a solve and make the subject and just a manipulation. So I want to start with the manipulation. So we have that x is log a and y is log b, and we are asked to write log of 100 a squared over b in x and y. Okay, so first thing is this logarithm here is a fraction, so the first thing I'm going to do is use the second log rule to split it up with a minus in it. So we've got log of the numerator minus log of the denominator. This one here is a product, so I'm going to use the first log rule to split that up. So this one goes to log of 100 plus log of a squared, and then this one just gets written on the end, so minus log of b. And then we've got this one here which has got a power in it, so the power is going to drop down the front. So I'm not going to do anything with the log 100 yet. Drop the power, plus not equals. Drop the power to the front. And nothing going on with the log b. Everything's split as much as it possibly can be now. Now remember, if we don't have a number written as a base, we assume that it's base 10. So log of 100, with what power of 10 gives me 100, that's worth 2. Don't know this, and I don't know this, but I am told that log of a is x, and log of b is y. So I'm going to end up with 2 plus 2x minus y. There we go. All my logs have disappeared, it's just in x's and y's. So the next one is a change the subject. So we have make y the subject. Of e to the 2y plus 1 equals x plus 5. That's a very dodgy 5. So we've got an e here, so we're going to have to use ln, so the natural logarithm. It's the only way I'm going to be able to get rid of that e and bring the index down. So I'm going to log both sides so that I can cancel out, oops, I want ln of e to the 2y plus 1 equals ln of x plus 5. So the power is going to drop down to the front, or you can say that a ln and an e cancel out. Whichever way you want, eventually the ln and e are going to cancel out anyway. If you drop the power to the front, then you're left with ln e, which disappear. So we end up with 2y plus 1 equal to ln x plus 5. I'm going to take off the 1 and divide by 2, so I end up with ln x plus 5 minus 1 over 2. There we go. And the last one for this one is a solve. So solve log to base 2 of x plus 1 is equal to 5 minus log to base 2 of x plus 2. Right, well, we need to get rid of these logs, really. Or we could get all the x's on the same side, it doesn't really matter that much. Let's get all the logs together, see if that helps us. So we've got log to base 2, what about 5? Looking at the next bit, 1. If I add this over, I'm going to get log to base 2 of x plus 2 equals 5. Now I can use this as a plus, so I can multiply the two things inside one log. So I'm going to get x plus 1, put a square bracket in there, x plus 2 is equal to 5. Now I really want to get rid of that log, so I'm going to raise it. So 2 to the power of, oops, 2 to the power of log 2, square brackets, x plus 1, x plus 2, equals 2 to the 5. So my log 2 and my 2 are going to cancel out and these are going to drop. So x plus 1, x plus 2, and 2 to the power of 5 is 32. Okay, so this is now going to be a quadratic. If I multiply out these brackets, I'm going to get x squared plus 3x plus 2 equals 32. Take off the 32 and solve. It's not going to factorise, so I'm looking for either using the quadratic formula or completed square form or polysolve if you have that in your calculator. I'm going to go with completed square. I hate relying on my calculator too much. I mean, yeah, fair enough, use it, but you know, you really should be showing how you could get the answer anyway. So I'm going to complete the square. 3 over 2 minus minus 9 over 4 minus 30, so x plus 3 over 2 squared. 4 30s is 120, so minus 129 over 4. So x plus 3 over 2 is 129 over 4, square root, and then take off the 3 over 2. Negative 3 over 2 plus or minus square root of 129 over 4. Now, if they wanted an exact solution, obviously that's what you would have to type or write. If they do ask it for decimals, you had two options. So x was 4.18 or negative 7.18. Now, if you stopped there, you may lose a mark. Depends on the exam or depends on the question, how much is worth and all that jazz. You would have to state that x cannot equal negative 7.18 because, that's the shorthand for because, that one's there for, that one's because. Brain. If you go up to the original, you're trying to log x plus 1 and x plus 2. Either way, you're trying to log a negative. Right, so log of x cannot be negative. And if you can hear a weird chattering noise in the background, that's my cat chattering at birds. Or you could say that log exists in the positive values. Something like that. Somehow you've got a reference that you can't log a negative, however you choose to phrase that. Right, that's it for today. Bye.